Good. So let's take a look at our review. I've got exactly the same problems on the smartboard as you have on your sheet. So let's kind of take a look at these, walk through these, because again, if we're good with this review, we should be pretty good with the quiz tomorrow, because very, very similar types of questions. Of course, the patterns will be a little different. You're going to have to recognize new patterns, but not so bad. All right, so first pattern, A26, B25, C24. It says give the next two in the pattern. So what are the next two going to be? D and what? 23. And that's a pretty obvious pattern. I mean, alternating letter and number, and the letters are just going A, B, C, D, and the numbers are counting down. Pretty easy. Next we have our wonderful little spider web pattern, which was kind of a pain. But we'll just draw one extra one. I promise you on the quiz it will not be so complex. Okay? It was just one picture, I guess, that was easily available for the review. We'll just draw one of them for right now. Okay? So it's 1, 2, 3. So we had 1, 2, 3. That one was poor. That one went the wrong way. And so what do? We added a fourth layer. And the fifth one, we just add a fifth round. Okay? Spider got a little bit, I know, confused there. It happens. Maybe the wind blew a little or something like that. I don't know. Very strange. Yeah, that's about the limit of my artistic ability right there. So you get the idea.
It's beautiful.
It was.
Frame it. Going on for $1 million.
No. Yeah. Roughly stick figures. That's pretty much my limit. All right. Rewrite a conditional and if-then form. So writing a conditional statement. Now, again, the instructions are pretty obvious here. If you read the instructions, it's pretty clear what you need to do. Write it in if-then form. So what's the first word that should be written down here? If, and then there should be a then coming at some point, right? If what? If you are a child, then you must attend school. The biggest thing I can tell you is don't get lazy with these and try to cut words and phrases out so you don't have to write so much, because you'll change the meaning. Okay, you're going to have to write some sentences here. They're going to have to be sentences, not, So do your best. I mean, my handwriting is hardly perfect. I'm not going to be judging for perfect handwriting. But try to keep it marginally legible so I can read what's going on. Okay? Write the converse. Now remember, converse has nothing to do with shoes. Right? Not in this context. What does the converse do? Flips it. So what do we start with in a converse? Okay, but what's still my first word? If. If what? If it's a mammal, or if an animal is a mammal, which almost kind of rhymes. And here you do have a little bit of flexibility, and this is just English. So I'm going to take a very, very, very dangerous and brief drift into the world of teaching English, which I am absolutely unqualified to do. But subject of the sentence, what is the subject? Okay, the animal is a bear, yes, okay? But the animal here. And the pronoun it refers to the animal, right? So generally we put the animal before we put the pronoun it. Now, I'm not going to penalize you if you do the it first. I'm really not going to penalize you for putting a pronoun first and then the noun it's actually modifying later. Okay? But according to English, you should put the noun first and then the pronoun afterwards, right? Okay? Not that critically important. I'm not going to downgrade you for that. But generally, the way I would write this, I would write if an animal is a mammal, then it is a bear. Okay? If you wrote if it is a mammal, then an animal is a bear, I'd be fine with that. I would not take off any points or think any less of you as a human being. But just for convention's sake, I do it this way. By the way, is this a true statement, the first one?
Oh, no.
The top one?
Yes.
If an animal is a bear, then it's a mammal. Yeah, that's a true statement. Second one is not. Give me a counterexample. Prove to me it's not true.
I'm a mammal.
You're a mammal?
I'm not a bear.
Are you sure? Okay. Yeah. I'm smarter than the average bear. Okay. Yogi Bear, anybody? Yeah, there we go. All right, there you go. Hey, boo-boo. All right, right as a biconditional statement. Biconditional uses what magic little phrase? If and only if. And the if and only if goes at the beginning, the middle, or the end? In the middle. In the middle. Phil, it was a 1 out of 3 shot. She took a shot. Points for taking a shot. You miss every shot you don't take, right? So if you at least take a shot, you might get it right. All right, so what are we going to start with then? So in order to make it a biconditional, we're going to get rid of the if and the then, right? So this has to go away. Okay, and the if and only if goes right in the middle. So I rewrite this two angles are supplementary if and only if the sum of their measures is 180 degrees. There we go. We're done.
I knew that too.
What?
I knew that too.
It's Monday. It's Monday. Grace is given. All right. So there we go. That's biconditional. Definitely need to know how to do that. Find a counterexample to show the conjecture is false. A counterexample. So the quotient of a negative number and a positive number is positive. That's something you do need to know. Division. Quotient means division. Yes. Okay. Sum is addition. Product is multiplication. Quotient is division. Difference is subtraction. Those are words we should be knowing at this point. So I need a counterexample to prove that's false. Now, this one is actually ridiculously simple because the statement is clearly false. The quotient of a negative number and a positive number is always what? Negative. So what's the counterexample going to be?
Negative 2 divided by 1.
Okay. There we go. Basically, any division problem involving a negative number and a positive number will be a counterexample. Any one you can think of. Unless you divide by 0, which is not allowed, which is very, very bad. Infinite. It's undefined. Okay, we can't divide by 0. No 0 denominators, remember? Fractions, no dividing by 0. Okay, If a person likes to sing, they are inquire. Counterexample.
Your parents make you do it.
Parents make you what? Be inquire? Make you do it. You're going to have to define it a little bit better for me.
I'm not even.
I like to sing and I'm not inquired.
Peyton likes to sing. Sing, but she's not in choir. Or and obviously it could be just, you could put insert whatever name you want there. My grandma likes to sing, but she's not in choir. Or my mom likes to sing and she's not in choir. Or okay. Well, if that exact question comes up again, then you're in luck.
Or you can just use it all the time.
Peyton. Well, I mean, with three of them in here, you're likely to be right on one count, right? Did I spell it right for you?
Yeah.
I did? Okay.
Her parents weren't quite sure how to spell the right way.
Actually, I like the way they spell her name better than I like the way that you spell
Oh.
So, ooh.
Sorry.
So actually, I didn't even think about it. I just spelled it that way. That's. I think a nice spelling is. I like that. All right. Use inductive reasoning to make a conjecture about the given quantity. Then use deductive reasoning to show the conjecture is true. Okay. This is a little trickier. This is trickier. The product of a positive number and a negative number is
Always negative.
is always negative. Okay? Okay? Use deductive reasoning to show that this is true. Now, this is actually a little bit tricky because the inductive part of this actually, the inductive reasoning, this is more the deductive part. The inductive reasoning part might be like 3 times negative 1 equals negative 3. 7 times negative 2 equals negative 14. 10 times negative 5 equals negative 50. Okay, this would be the inductive portion. By the inductive, what they're looking for is a pattern. And so with the inductive reasoning portion, what they want you to do is actually find the pattern and demonstrate that there is a pattern. Okay? The deductive reasoning is really the final statement. And proving that's true is really way beyond our capabilities at this point. We wouldn't actually be able to prove that it's true. We just want to make the statement. So it's a little bit, that's one of the trickier problems on the test. Just because the inductive part is where you want to show a pattern, the deductive is where you make the conclusion. But proving that would probably well beyond our ability at this point. Using law of detachment. Now, there's a little hint here. Which law are we going to use? Detachment. And the detachment law is the one that's so simple it's hard sometimes, because detachment law is the one that says we're given a rule and then we're given a circumstance. It's a one-way street, and as long as we're given the front, we can go to the end. Right? So the rule is if you eat a healthy breakfast, then you will not be hungry until lunchtime. That's my rule. I'm not saying that's a true statement. We're going to assume that's a true statement for the purpose of law of detachment. Okay? We're going to assume that rule is true. You ate a healthy breakfast. Therefore, you will not be hungry till lunch. Whoa. Okay? Now, what if instead of the second part being you had a healthy breakfast, what if I had given you this? You are not hungry until lunch. Could you assume that you had a healthy breakfast? No. Remember, law of detachment is a one-way street. Okay? It's one way. You have to start with a hypothesis and end with a conclusion. I can't start with a conclusion and go backwards to the hypothesis. Do not go the wrong way down a one-way street. Okay? That's law of detachment. If possible, use law of syllogism to write a new conditional that follows the pair of statements. If a polygon has three sides, then it is a triangle. If a triangle has two congruent sides, it is an isosceles triangle. Okay. Law of syllogism is my chain of events. That's when we watch the commercials, right? Okay. Does this fit the qualifications for a chain of events? No, it does not. Why not? Right. Because this conclusion has to match this hypothesis. And they both include the word triangle, but this adds new conditions to it, doesn't it? Has two congruent sides. So no conclusion is possible from this. Now, do be careful. Sometimes it gets tricky. Sometimes this is my first statement and this is the second. Sometimes we put them backwards. I might say, if I go fishing, I'll catch a bluegill. If it is a nice day, then I'll go fishing. Okay? Is that a law of syllogism situation? Yes, it is, because it's just we have to start here. If it is a nice day, then I'll go fishing. If I go fishing, then I'll catch a bluegill. So therefore, if it is a nice day, then I'll catch a bluegill. Okay? Sometimes when you're presented with the information, we have to read the bottom one first and then the top one. So look to see if the chain of events happens top to bottom or bottom to top in the two sentences. Okay? Either way. Because you'll note, then I'll go fishing. The conclusion here is exactly I go fishing, the same as the hypothesis there. So my chain starts here. There's the start. And here's the end of the chain. Okay? And remember, so if we're going to make a conclusion, if we're going to write our conclusion, then my conclusion would be if it is a nice day, then I'll catch a bluegill. I can't spell. Okay. So be careful with those, please. True or false, and not everything would actually cut and paste nicely, so I'm going to have to write in a few things, but that's all right. Can you determine, based on the picture, whether these things are true? So plane S and plane T intersect. Is that true? Yeah, I can definitely make that conclusion. Points H, A, and D are collinear. No, I cannot make that assumption. Okay? That's a false or true. Next is angle FCB. Is a right angle. Hold on. Wow. Not just no, but heck no, huh? FCB. You sure it's not a right angle? I mean, it kind of looks like if you look in perspective. Oh, we don't have a little right angle box, so that's a false. Okay. Then it was blank and AC are perpendicular. Now, and there was nothing written there, but did it matter if anything was written there? Is AC perpendicular to anything, according to this picture? No. So it's automatically false. Okay. I could say anything. I could say EB and AC are perpendicular. I don't know. Can't make that conclusion. Maybe. And finally, AC and DE lines. AC and DE intersect. Can I make that conclusion? Where do they intersect? At B. So that's true. Okay. That concludes our review. That's everything on there. Hopefully after this, you feel like you're going to be ready for the test, for the quiz tomorrow.